Thank you. I'm Ville Aikas. I work at Google, and I work on Knative, and more particularly lately been working mainly in the eventing side of the Knative project.
I'm Matt. Is this on? OK, it's on. I'm Matt, and I work with Ville. I mainly focus on the Knative serving project. So one of the aims of Knative is to, well, serverless on Kubernetes, but one of the aims of our repos is to be loosely coupled. And what that means is we want build, serving, eventing to be independently installable and useful, but work really well together. About a year ago, Ville and I were sitting by the whiteboard trying to figure out how we make this happen. So we wanted to solve, in particular, the problem of how with eventing we make it so that we can deliver events to the serving abstractions, for instance, service, but also make it so that we can deliver events to things that we haven't thought of yet or you haven't thought of yet, like this. One of the problems with these object references, though, is how you deal with what's on the other side, right? It tells you what the resource is, but what can you do with it? So option A, you bake it in, right? So we start by saying, OK, I know I want to deliver things to a service, and then this Hutchinson thing, and so on, and so on, and so on. And it gets really tedious and unwieldy, and especially in environments where you might not know yet about the things that you want to deliver events to, for instance. This doesn't really work.
So we got back to the whiteboard, spent a bunch of time thinking about this, and we decided that option A is probably not what we want to do. So we came up with this option B, which is what we call what the duck. And in particular, what we wanted to do was really boil down the problem. What problem are we really trying to solve? Not necessarily sort of kind of what is it that we want to be doing with those types in particular, but what is the thing that matters to us about those particular objects. And the pattern that we had seen in the past for something like this was, oh, by the way, and our esteemed colleague there will be handing out stickers later. Thanks, Scott. So we kind of went back and started looking at things, and we're like, well, what we really care about is what's on the other end of that reference, right? We don't really necessarily have to know exactly what is in there, as long as it can fit the bill, and you can read the definition for duck typing there. But this is what we started to look at as a possible solution. So if you look at these objects here, so this is just handy-dandy JSON / YAML there. And in these cases, if we only wanted to go ahead and care about things like foo, whatever is underneath the foo there, there's 3 different kinds of objects there. And even though they all look a little bit different, they have the small section that, that we care about for our cases. So we're like, OK, great. Let's go and define a partial schema for that. And then we started looking a little bit more, and we were like, you know what, this looks really familiar. We've already sort of kind of seen this. So if you look at the Kubernetes objects, you can see that each one of them always has the handy-dandy type meta. So it basically says, this is the kind of an object I am. This is the group I belong to, and I'm that type. And then you have the object metadata that describes the actual object. What is it? So if you create a service, you give it a name and a namespace and a few other things. And lastly, where we see this often is in the status. So there's API principles document. Each one of these Kubernetes objects should be providing a status in a well-defined manner so that then you can tool them better, yada, yada, yada. And then we started looking at even more of these types where we see this on the spec side of things. So those were the common wrappers. So if you look at the apps v1, so you have the deployments, the stateful sets, and the daemon sets. And again, here you can see that they are sharing some common ways of selecting things. They also have this thing here called the pod spec template that allows you to go ahead and reuse that thing for common shape and so forth. So we kind of went there and said, do you think it would be bad if we went in and defined this, like what could we do with this? If we basically said, let's go and give it the two Kubernetes type meta, object meta, and then let's define our own little pod template spec that gives us an aggregated object or with using that field only alone. And if you look at it, it maps into those things. But for example, in the case of the deployment, the grayed out pieces are not part of that spec at all, right? So let's go and see what we can do with something just with this.
All right, so for our first demo, we're going to use a little prototype that we wrote a few months ago, well, maybe more now, called Cashier. So in Knative, we have this image cache resource that we create as part of our object model directly that gives a hint to controllers that allow you to potentially cache a particular container image across the cluster for fast startups. That same problem, though, afflicts all of the Kubernetes app resources we just saw. So the question is, can we write a generalized controller that uses this partial schema to figure out what the container images are and basically bring that same abstraction to all of those Kubernetes application resources? So, OK. So with duck typing, though, right, I don't need to know a lot about the type. I just need to know what set of group version resources adhere to this partial schema. So in here, the entire awareness Cashier has of these types is basically these strings and the partial schema that we have defined. So what we're going to show in this demo is we have this with pod partial schema. We're going to create a deployment with an Ubuntu image, and we're going to see the controller produce an image resource with Ubuntu. And then we're going to create a daemon set resource with two images, Debian and Alpine, and it'll produce two image resources. So let's see that in action. All right. So if I switch over here, let's make sure it didn't drop. OK. So you can see on the left here, there's a deployment YAML with the Ubuntu image. And if we scroll a little bit, you can see the daemon set at the bottom with Debian and Alpine. And so if we apply this YAML, in the bottom right, I have a watch going to see what resources exist. So Cashier. OK. So when I apply this, you'll see the deployment and the daemon set appear immediately. And the controller has already picked up the fact that these with pod resources are there and create these image resources for each of the three images that it sees. So if I go in here and I delete the deployment, you'll see that one of the image cache resources for the Ubuntu image goes away, right? So this gives us a way to hook into the Kubernetes object lifecycle in order to know what things to cache, what things not to cache. And if I go in here and I delete the daemon set resource, everything goes away. So
cool. So that was pretty neat. So we were able to go ahead and have a single controller that has no knowledge of those particular objects in there. We were able to go ahead and just say, look for these resources and do something nifty with them. So that allows us to go and reuse the very same controller for any additional resources that might come. So if somebody else builds any kind of a thing that fits that using the pod template spec, we can now go ahead and start getting the bennies of the cashier. And the other nice thing about this one is that just like in Go, when you use interfaces, you don't actually have to do things like in Java where you say like the resource implementing that needs to know what it's implementing. So the nice thing about this is that all those native Kubernetes native resources, they don't need to be aware of this duck typing that we are doing in the background at all. So that was cool. We were pretty happy with that. But then we got in the point where we were like, OK, that really solved our goals for being able to read arbitrary state for anything that adheres to those particular partial schemas or duck types. So So if we go back into the apps v1, if you look at these objects again, if we were to go ahead and just, let's say we wanted to go ahead and add like an environmental variable, let's say we are doing something like injecting some values in there or something like that. The tricky bit about this one is that if we go ahead and come in, read the object, modify it, and just write it back using our duck type, then some of those things wouldn't be carried through, right? So we would just basically badness would happen. So we didn't want that. So we are back to option A, right? Guys, remember this? So it didn't solve our problem at all for the writing cases. And that made us sad. But we were like, but again, like we don't need to know what the type really is. All we need to know is know enough about it to understand what are the bits and pieces we need to change. So let's take away all the cruft from the previous objects that we had, and we were like, what would the wire format actually look like for these things, right? And it really is just, this is it. It looks the same for all of them. So if we just go ahead and actually generate a patch against our duck type, then the nice thing is that the right things will just magically happen. So if you look at this one, this one has no knowledge anywhere in this about the object on the other end. It just knows that it needs to go and modify some bit somewhere in the YAML on the other end of it. And it works great against all the app types. So Matt, oh, that one.
All right, so for our second demo, we're going to show how we can use a patch to modify arbitrary objects. So there's this second prototype that is called Boomaps. It's named after this little ghost here that you may recognize that freezes when you look at it and moves when you don't. So this was a prototype that we put together that attempts to help alleviate problems with config map rollouts, where if you use them in environment variables, old pods don't change, and but new pods get it right away. And if you use it via volumes, you can't control how quickly that is rolled out to all of the pods consuming it. So what the Boomaps do is you have this mutable map and this immutable map, and as you change the mutable map, much like configurations and revisions in the Knative serving model, you get new immutable maps for each state of your thing. So now if you want to deploy something, a with pod, for instance, that references the mutable map, because typically that's what you want to reference when you're doing development, but freeze it so that it doesn't change out from under you and you can control the deployment of the rollout of the changes, the config changes. We run a mutating webhook that basically intercepts with pod, and the mutating webhook, you guessed it, returns a patch to the API server for the changes it wants to make. And so we can use this to basically freeze the config map references to the latest generation of the mutable map, and then it won't drift as you continue to edit your mutable map. So let's see this in action. So if we go over here, I'm going to switch to boomap.yaml. OK. So this is just a really simple boomap where the spec is basically much the same as config maps data. I have foo bar, and if I deploy this, in the bottom right, you will see right away the mutable map. Right away, OK. The mutable map appear, and the first generation of the config map appear. All right. My connection seems to have dropped, so give me 1 second while I reconnect. How's everyone doing? All right. So what we're going to do next is we're going to deploy, just like in the example, a deployment that references the mutable map. So we have boomap deploy here. And you can see this references the mutable map, which we had named freeze.me. Oh, wait, sorry. Got distracted. We need to change this boomap at least once to say KubeCon. OK, and if I apply this, It's dropping every time I switch to this frame. That's awesome. Oh, maybe not. There we go. I had hit something. OK. So in the bottom right, you now see the second config map appear right away. And now if we go and deploy that deployment, what we will see, kube control apply -f, boom app deploy. You'll see the deployment appear in that bottom frame right away. And I'm going to zoom in because this gets a little big. So we're going to get the deployment and look at what we got. So if we scroll down here a little bit, you can see that the mutating webhook was able to change, it look through, find that boom app reference, and replace it with the name of the frozen config map. So that's neat. Now, if we were to change this, it wouldn't change out from under my deployment. But we haven't shown this applying to duck types yet. So let's look at another type that actually implements with pod. In this case, let's look at a Knative service. So you can see this similarly references the boom app, freeze me. And if we go over here and we apply that, we will see it start to appear down here in just a second. It creates a deployment under the hood. And if we kube control get kservice, show YAML, and I make this big, what you will see is here, this also can be frozen because it also implements with pod. And if I go over here now, and I refresh this, hello KubeCon. All right, so we saw it in action. So one of the nice things about this is this allows us to control the rollout and rollback of config maps, right? But we have shown that we can take this partial schema that allows us to read these things, but also use it to synthesize patches for changes we want to make to these things. And this allowed us to basically write a webhook that applied to any with pod thing, to write a webhook that could freeze these config maps in place as these with pod things get deployed. And so, so this lets us actually control the rollout and rollback of config map changes. So, right, your turn.
Thanks. So what does this have to do with Knative anyways? So where it all really began, again, just kind of going back to the beginning there where we said, we basically had these things called event sources that allow you to go ahead and come in and saying, hey, start sending events from here to there. And the way you specify there is by putting an object graph that basically, just says, okay, there's your version, API group, and the name of that particular object. So this was the very first one that we did, and just as we expected when we used these duck types, instead of baking in any kind of knowledge about the object on the other end by just using those duck types, so we spent some time thinking about what those duck types look. And then when we introduced a new object here in the latest 0.5 release of Knative for Broker, we didn't have to change any of those codes because they were able to go ahead and keep on working and just resolve those references and do what they wanted to in the first place. So all the contract, the very first simple contract or the duck type that we defined was this addressable, where in the status field you just needed to go and have an address and a host name in there. That's all that the consumer really needs to know where to send the events to. It was really that simple. So that was our very first duck.
All right. So after we saw that this could be used in eventing to allow us to keep, to decouple eventing and serving so that they could work well together but not without baking in knowledge, we started to look at another place where we had actually gone more with option A. And we revisited that and we looked at, how we were doing these, what I call just-in-time builds, where our configuration resource embeds a Knative build spec, and as revisions are created, as you post updates to the configuration, it stamps out builds and revisions, and then the revision watches the build that the configuration created and waits for it to be complete. And so basically, all we really needed to know for that thing we're watching, the build reference, was has it succeeded or failed? And so we leveraged this sort of condition duck type and some of our own conventions around particular conditions that our resources should expose to be able to basically watch arbitrary build-like resources run to completion as part of serving. And this has enabled us to decouple serving from build in much the same way we decoupled serving and eventing. This also enabled us to, as we started pipelines, which ultimately became Tecton, slot those in on day one so that you could use a task run or a pipeline run just as you could use build. And we literally changed zero code because they just worked. So, and that was in point 2. In point 6, we started to really embrace the duck. One of the changes we've made as part of our new API shape in point 6 is we started to reshape the actual serving API to embed a pod spec in the same way as the app's resources. So this is what we saw in that second demo, which enabled us to create patches that work equally well against Knative service and configuration resources that work against Kubernetes application resources. We also created our own duck that allows us to manipulate routes and services in much the same way and get some amount of client consistency in terms of how we generate patches to do rollouts. We also started to use ducks on the inside in point 6. We were using the scale sub-resource for our auto-scaling previously, but we felt a little limited by the set of things it exposed to us. And so we actually changed to using something that we call pod scalable, where we basically spec'd out the pieces of the thing we're scaling that we need to either read or mutate, such as the replica count in spec and status, the selector, and the pod template spec. The pod template spec is a notable thing that isn't in the scale target resource. But by having it in here, we can potentially start to do things like mutate the resources block if we want to start to integrate vertical pod auto-scaling in the future, or read out pieces of information to do more sophisticated scheduling. I don't think we had an animation here. OK.
All right. So hopefully we have been able to go and demonstrate and show you, or at least get you excited about how cool this is, and maybe you can see some uses for yourself for this. So this is not just limited to Knative. One of the things that we mentioned earlier on is having several kinds of, we talked about the different components of the Knative. So we have like serving and eventing and build. But the other thing we also have done is we have created this repository called PKG, package. And many of the tools that we have written to support the duck typing have been moved over there. And you can go and use that if you are writing controllers, or if you are writing any kind of tools that might just want to go and operate on generic resources. So those of you that have written a controller or have used, well, typically you use informers there, but if you have used the Kubernetes informers before, this code looks probably pretty familiar, but it basically just says, in this case, what we do is we say, let's bring in the dynamic client from the Go client, and then we introduce a typed informer factory. So notice that it's typed there, and what we are doing is, in this example, we are using the V1, the with pod that we have been talking about, the partial schema. So the nice thing here is that is the setting up the informer. It should look and feel very, very familiar to you if you've used those before. And the only thing here that is talking about the kind of thing it watches is that GVR. In this example, we hard-coded that to demonstrate that, so it fits in the slide. But this could obviously come from the strings like in Matt's earlier example, or from config maps, or wherever you want to get those. Or it could be an object reference, like in our case, where we bake in. That's why we use so much of the object references in our object model, because then you can just read when you go and create the object in our controller, we just read it from there, and there's no knowledge of any of this stuff in there. Then you go and grab yourself an informer lister, and then you are off to the races. Then you say, hey, when that informer notices something, go ahead and call something. So for example, in the controller land, you typically have something like this, where you have a reconciler. So the happy little reconciler is there, and it is now using the lister just like you would do if you were to go and grab that from the typed clients that you generate typically. And now you have this cast here that basically says, well, I asked for with pod objects. I know they are V1 objects, and you don't have to go and do the tip, because you could do this also by running unstructured objects and everything else, and you would have all the fun of doing your little JSON marshalling and everything else, and you know, that's fun. But this is a little bit nicer, I think, and more concise. So we have the benefits of being able to get strong typing and being able to go ahead and get the standard informer caching behavior you get out of that. So it should be very easy to go ahead and utilize these things. And strong typing until soon.
Thanks, Ville. All right, so that showed the informer lister pattern. Is this on? Can you hear me? Yeah, okay, sorry. So let's look at patching. So this example is actually real code that is part of Knative serving in 0.6. I mentioned pod scalable before, and how we actually use pod scalable coming from an informer like Ville mentioned in the previous example. Here we have a pod scalable that comes in at a desired scale and should look very familiar, right? We create a copy, we change it in a very typed way, and then we create a patch from the difference from what we changed and pass that through to the dynamic client as a patch. And that is it. There is no step 2, right? Like, this is all of the code we needed to generate the patch, and everything else is helper libraries. A couple other useful tools. Type assertions. So one of the things we wanted to do is make sure that as we started to produce these contracts like addressable, as Ville mentioned earlier, as the contract between serving and eventing, we wanted to make sure that things like the serving's service object implement that. And so this basically just does a simple little trick where it populates all of the fields in the addressable and then makes sure it can round trip through the service resource without dropping anything, to make sure all the fields are there and in the right spot, etc. Another really useful thing when you're dealing with duck types, and thanks to Paul Mori for pointing us at this, is aggregated cluster roles. So in this case, you can see the role that we give to the serving controller, and it uses a selector that says serving controller true. And if we want to integrate with build, there's no knowledge baked into the code or the default roles that says, hey, I know how to speak to build. But you can glue them together by granting access by just creating this cluster role that gets pulled into the selector. And as I mentioned before, when Tecton became a thing, we could add it simply by gluing in another role that just becomes part of this selector. So, yeah. Okay. One more thing. So in Knative, we mentioned earlier, we aim to be loosely coupled at the top, but also we talk about being pluggable at the bottom. So loosely coupled at the top, right, is via the duck typing. But we didn't really talk that much today about being pluggable at the bottom. So there was actually a secret cameo in our presentation, our demo. That last serving demo where we loaded up the service that said, hey, KubeCon, was actually running Ambassador. So the pluggability at the bottom enables us to replace subsystems. Joe Burnett and Mark gave a fantastic talk last KubeCon, last December, on doing this with the autoscaler. Networking is another place we can do it, and we have a number of places we do this in eventing. So we've really just scratched the surface of the extensibility within Knative. Yeah, so little surprise for you. OK, so at this point, we are ready for questions, and we're going to put up a wall of links while we answer questions.
Just a quick reminder to rate the session at the end. No questions? Someone's got to have one.
All right.
OK,
Scott
going.
has stickers.
Oh, I see one.
Hi, so I was wondering, when is the Ambassador kind of ingress controller going to be available instead of Istio for general availability?
Oh, sorry. The Ambassador integration here, so I think documented today, we have Istio, and I believe we have Glue integration. The Ambassador integration we showed here is a POC that Ben Browning put together, although we were talking to them earlier on the floor about actually getting proper integration together. So I don't have a date for you, but we want to talk to them about adding proper support. But OK, I didn't link to Ben's prototype, but I can send you a pointer if you're interested. Yeah, also, for all the things we don't have links up here for, we are very active on Slack. So if you go to slack.knative.dev, I believe it generates an invite for you, and you can log in and chat with us. These lights are blinding. Yes, I know. All right, thanks everyone. Scott has Knative a whole bunch of stickers in the back.